Let us now apply the knowledge of postulates and discuss these statements. The question here is, determine whether each statement is always true, sometimes true, or never true. The first one is, if points A, B, and C are non-collinear, right, like this, then segment AB, BC, and CA are contained in exactly one plane. The whole segment AB, BC, and CA are contained in exactly one plane. The second one is, if points A and B are contained in the plane K, so there are 2 points A and B, then the segment AB is perpendicular to the plane K. And the third one is, two planes intersect in a line. I'd like you to pause the video, answer the question, and then look into my suggestion. Now here is how I will do it. The first one is, if points A, B, and C are collinear, then segments are contained in exactly one plane. So we have 3 points, as we know from the postulate 2.4, that a plane contains at least 3 non-collinear points. So if we have these 3 points, and let us see if these points are A, B, and C, then we know that a plane will uniquely contain all these 3 points. Now the question is whether the line segment joining these points will be contained in the plane or not. That is the question, right? So for that we have a postulate and says, if 2 points lie in a plane, then the entire line containing those points lie in the plane. So that is section 2.5, correct? So from 2.5 and 2.2 we can reason it out, right? So section 2.2, which defines a plane having 3 points, and then 2.5, which says if 2 points are contained, then the whole line is contained. Therefore segment AB will be contained. Now similarly, if these 2 points are contained, the line BC, and therefore segment BC, will be contained within the plane, right? So this is always true. So the answer is always true. So the type of proof which we have given, or the reason which we have given, is set of statements which could be formed as kind of a paragraph, right? The second one is, if points A and B are contained in the plane K, so these 2 points are contained in the plane K, then the segment AB is perpendicular to K. Well, that is false. It is within the plane. It is not. So it is false, or I should write never true. So it is not perpendicular, it is within the plane. It lies in the plane. The third one is, 2 planes intersect in a line. Well, if 2 planes intersect, then they will intersect in a line. So whether the statement is true or false, that is what you have to figure out. It is sometimes true, since that statement if is missing. You see, if. So that is what is important to understand. So 2.7 says, if 2 planes intersect, then their intersection is a line, right? So it is sometimes true, not always. So that is how you can answer your questions, correct? So go through these postulates and understand what exactly they are. Just to remind you, the first one defines a line. It says 2 points will define a line. Second one says 3 points will define a plane. Third one says a line contains at least 2 points. It could contain infinite, right? Fourth one, plane contains at least 3 points. Fifth one, if 2 points are on a plane, then the whole line containing those 2 points will be contained in the plane. And 6 and 7 is about intersection. Intersection of 2 lines, if they intersect, is 1 point. intersection of two planes, if they intersect, will be a line. I hope with this we can wind up and have a test problem in the next video. I hope that helps. Thank you.